Hello students, so today we will do numericals on error analysis. I hope you have revised this theory of this topic and learned the formulae that we have derived. The first sum will revise our theory of various terms of this chapter. So the sum reads that there is a simple pendulum and a student is measuring the period. So the period that he measures are 2.63 seconds, 2.56. So around 5 periods, 5 readings he has taken. So we want to find the mean value of the period of oscillation. So that is quite simple. So we have to add all the 5 periods that are given to us and divide by 5. So this will revise our first formula, that how to get the value of period of a true, this is mean value, is called the true value. So exact value of oscillation, period of oscillation is 2.62 seconds. So as this is the true value, now then the next question is we have to find the absolute errors. So this is the true value. Absolute error is true value minus the reading. So 2.62 seconds is my true value. So this will come in left side. And I am subtracting by the various readings that I have got. And I am not putting the sign because it is absolute error. So the signs are always I am taking positive. So these are the 5 readings I have got. Now I have to calculate the mean absolute error. So mean absolute error would be, I should add all these errors and divide by 5. So that's what I have written. Here I have written the formula. So I have to add all the 5 readings of errors and divide by 5. So I have to round to 2 places because he has given, we are taking the reading in 2 decimal places. So my second place is also a place of doubt, so there is no point in taking the third or fourth places. So when I divide, I should round by the 2 places. Then relative error is absolute error upon the true value. So this is my absolute error, average mean absolute error divided by 2.62, which is the true value. So I will get relative error. And percentage error means multiply by 100. So 0.04 into 100 will give me 4%. So this is the percentage error. Now you have to be careful in numericals. If they say give the answer in terms of absolute value, then I should write 2.62 plus or minus 0.11 second absolute time. In case they say give in percentage error, then I should say 2.62 second plus or minus 4%. So this answer is in terms of percentage, this is in terms of absolute error. So this sum has been given so that various terms will get revised. Is it okay? So now we will go to other sums. So sum number 2 reads that there are 2 resistances. R1 is 100 ohm plus or minus 3. So this is in terms of absolute errors. R2 is 200 plus or minus 4. They are connected in series. So when they are connected in series, what is the value of R equivalent? R1 plus R2. So 100 plus or minus 3, 200 plus or minus 4. So this will give me 300. And when we have to do the addition, then absolute errors get added. So plus or minus 3 and plus or minus 4 will give me plus or minus 7. So this is the answer. This we have learned while discussing the theory that whenever there is an addition or subtraction, the absolute errors get added up. So this is to revise that formula. Now next sum. The resistance is VR is equal to V upon I, which you know by Ohm's law. Now voltage is given to be 100 plus or minus 5 and current is 10 plus or minus 0.2 ampere. So this is my error band, this is my error band, and so percentage error in V would be how much? It is 5 volt is the error out of 100 volt. So percentage error will be 5 upon 100 in 100, which I will get 5%. Error in current would be 0.2 ampere is the error out of 10. So 0.2 upon 10 multiplied 100 will give me 2%. So I have calculated my error, which was given in absolute terms in terms of percentages, because I want to find percentage error in R. Now whenever there is multiplication or division, we have learned that percentage errors get added up, not the absolute errors. So I had calculated this percentage errors. Now so percentage error in R would be percentage error in V plus percentage error in current. So 5% plus 2% is 7%. So this will also now revise on second formula that we have derived, that in case of multiplication and division, we have to find either the fractional errors or percentage error. Is it okay? Now we'll go to next question, question number 4. In this question, the percentage error in measurement of mass and speed are given. So 2% is the error in mass, and in speed the error is also 3%. So you say what would be the maximum error in kinetic energy. So we should write the formula of kinetic energy. Kinetic energy, you very well know, is half mv square. Constant has no part to play in calculating the error, but now here there is a multiplication. So percentage error in kinetic energy would be percentage error in mass plus this is v square. So 2 multiplied by percentage error in velocity. So percentage error in mass is given to me 2%. Mass is given to me 2% and velocity is 3%. So 2 into 3 will give me error in if I add both this, I will get error in kinetic energy. So error in kinetic energy from this formula would be percentage error in mass plus 2 multiplied by percentage error in velocity. I have substituted the values, I have got 8%. So you see the contribution of velocity because of v square is much more. See, velocity contribution is 6%, whereas contribution by mass is 2%. So means in case you want to calculate the kinetic energy, you should be very thorough in measuring velocity. Okay. Now next sum is important. It has been asked in JEE. So it will be slightly tricky. This is the period of pendulum. So this sum is based on period of pendulum. You know the formula that period is equal to T is equal to 2 pi root L upon G. Now the question is that what is the accuracy of determination of G? So he is measuring T and L. So there are three in this formula. There are 3 variables T, L and G. So period we can measure, length of pendulum we can measure. So he is asking what is the accuracy in G. So as I want accuracy in G, so to make G as a subject, you will get G is equal to 4 pi square L upon T square. This is algebra. So from algebra you will get this. Now delta G upon G into 100 means percentage error in G would be 4 pi square will play no role. L, so delta L upon percentage of L. So delta L upon L into 100 plus this is T square. Even if there is a division, we have to add. So plus 2 into delta T upon T into 100. So delta T upon T into 100 is giving me a percentage error in time. So I have to period. So I have to multiply by 2. So now when I substitute the values, now you see how to substitute the values. Delta L upon L. So how to get delta L upon L? you see, he says measured value of length is 20. It is known that the 1 millimeter accuracy. So accuracy is given to be 1 millimeter, means it is 0.1 centimeter. So accuracy in length is 0.1 centimeter and I am measuring 20. So my fractional error would be 0.1 upon 20. This is very important step. Delta L upon L, so it is 0.1 upon 20. Error in L upon the length. Similarly for the period, how he is giving? He says that he found the period to be 90 seconds. So capital T is 90. He is using a wristwatch of 1 second resolution. So delta T is 1. So delta T is 1 and T is 90. And so if I now put these values here, so I am getting the answer as about 2.72 or 3%. So the error in G would be around 3%. Is it all right? This is quite important sum. You should know how to calculate percentage or fractional errors when accuracies and data is given to you. ठीक है? So we will proceed further. Now, in this sum, he says a body is moving a distance of 13.8 plus or minus 0.2. So again, I have been given absolute errors. This is the distance, this is the absolute error. This moved in 4 seconds, plus or minus 0.3 seconds. So if we say calculate speed, so I know speed or velocity distance upon time. So I should calculate, I am first calculating V. How much would be V? This is 13.8 and time is 4, so this is my V. So first I have calculated V from the 8th standard, 9th standard physics. Now, fractional error in V. Now using this formula would be fractional error in distance plus fractional error in time. So I will calculate now fractional error in distance. What is fractional error in distance? What is the error in distance? 0.2 out of 13.8. So this is fractional error in time in distance. Then what is fractional error in time? 0.3 second is the error out of 4. So fraction in time is 0.3 upon 4. So knowing both the fractional errors, now I know the fractional error in V. Fractional error in V, so I am getting is plus or minus 0.09. Now but he is asking absolute error. I know fractional error. So this formula delta V upon V. Delta V upon V is equal to, I know the answer, 0.09. And what is V? V is 3.4. So my delta V would be fractional error into this 3.4. So if we multiply 3.4 into the fractional error, you will get the absolute error. So I can say my speed of the body is 3.4 plus or minus 0.3 meters, because this V multiplied by this number gives me the delta V 0.3, and V value I have calculated here. Is it all right? So we'll go to next sum. In the next sum, we are given the equation and percentage measurements are given. This is quite simple sum. Calculate percentage error in X. So percentage error in X would be A square. So it will be 2 into multiply by percentage error in A plus B cube. So plus 3 multiply by percentage error in B. C, though it is denominator, it would be plus 1 multiplied by percentage error in C, and this is root 2, so number is half. So this number will come half. So half multiplied by percentage error in D. Data has been given. To substitute the values, you will get this answer. So now see the contribution of all. Make the percentage error in X to 17.5%. Okay. Now 8th is quite important sum. It says there are two resistances, values are given. So this is value, this is the absolute error. R2 also I know this, I know this. I know the value of resistance as well as the band of error. Now, if so, the sum is of two parts. One, they are connected in series, and then they are connected in parallel. For series, it is very simple. We have done a similar sum. R equivalent is R1 plus R2. So R1 plus R2. So my resistance will be 4 plus 16, 20 ohm, and absolute error will get added up. So 0.5 plus 0.5 will give me 1. So my answer would be 20 plus or minus 1 ohm. In case I want to give the answer in percentage, then what is the error? 1 upon 20 multiplied by 100. So percentage error in R equivalent would be 1 upon 20 multiplied by 100. That will give me 5%. 1 upon 20 multiplied by 100. To get in percentage, 1 is the actual error and out of 20. So I will get 5%. Now be very attentive to understand how we calculate in parallel. This part you know. R equivalent is equal to R1 R2 upon R1 plus R2. Now just substitute the value. R1 is 4, R2 is 16, so you get 3.2 ohm. So far it is quite simple. Now pay attention. 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. Now differentiation you will be learning later on in mathematics. So if we differentiate both the sides, so remember, whenever there is 1 upon x, answer is difference of numerator or change in delta or error comes in the numerator upon square of the denominator. So 1 upon R general 1 upon R so 1 upon R differentiation is delta R, change in the value of R upon R square, derivative of this. Okay, so you learn derivative of this, partial derivative of 1 upon R is change in R upon R square. So 1 upon R equivalent derivative will be delta R equivalent upon R equivalent. Same thing here, delta R1 upon R1 square plus delta R2 upon R2 square. Now delta R1 and delta R2 are given. Delta R1 is 0.5, R2 is this, R1, R2 are also given. So you can get the right hand side. Then delta R equivalent would be R equivalent. Now R equivalent I have calculated here. So like what we did in the previous sum for velocity. So R equivalent I know, so I will get delta R equivalent as 3.2 multiplied by whatever answer I get here. So if you do the calculation, you will get 10.63%. Is it all right? Now let us do the last sum of today. The last sum data is quite big. Pay attention. He says the student is doing such experiment which will be learning later on in part 2 for calculating the Young's modulus of steel. So that is why he has given the formula. So we are only interested in this formula, y is equal to 4 mg into capital L upon small l into pi d square. Now what are these various terms that has been explained in this data? Length of wire is capital L. So he has given 2.890 meter and he has says this length is measuring using a scale of least 0.1 centimeter, means 1 millimeter. The diameter of wire is 0.082 centimeter which is measuring using screw gauge of least count 0.001 centimeter. Mass suspended by the wire is 3.00 kg. Then extension in length of wire. When you suspend a mass, the wire will elongate. So that elongation is 0.087 centimeter. That also is measuring using a screw gauge of least count 0.001 centimeter, and this formula he has given. So writing permissible error in y is quite simple. Would be would be percentage error in m plus percentage error in g plus percentage error in l plus small l plus 2 into percentage error in d. Now, so that's what he has written. But in g there is no error. We know the exact value of g of that place, because that we are not measuring. So would be delta m upon m into 100. This would be the percentage error in m. Delta L upon L into 100, percentage error in capital L. Similarly, percentage error in diameter would be delta D upon D into 100, and 2 will come because this is a D square and this is about L. Now, the important point in this sum is that how to get the values of these deltas. Delta's value is not given, though we are given the values of all, but delta's values are given in a hidden manner. So be careful and understand. So first we'll go to mass. Mass is says 3.00 kg. Now when he says mass is 3.00 kg, it's very important why he has written point and 2 zeros. So means my accuracy is up to second decimal place. So means my delta m is 0.01 kg. This is very important point, that delta m is 0.01 kg because we have written 3.00. Even if we have written 3.45 kg, he has given up to 2 decimal places, so my accuracy is up to 2 decimal places. So this is my delta m. Now so see for length. Length he has given 2.890. Here directly he has told least count is 0.1 centimeter. This is in meter. So 0.1 centimeter means 0.001 meter. So that is my delta L. So my delta L is 0.00 meter. So because error is equal to the least count of the instrument. Then for screw gauge, this is in centimeter, this is in centimeter. So this is my delta D, 0.001. Then small l, also he is using the centimeter. So this is my delta small l. Now knowing the value, if we substitute, we will get the answer. So my maximum error is, now substitute the values of everything, so we will get the answer. Okay, so which comes to about 4%. So maximum contribution in percentage error in y is by d. You see, this is 0.33, 0.35, 2.44, 1.15. If we calculate the percentage, so we are getting these numbers. So maximum contribution is 2.44. This is 0.33, so very small. So even if you don't measure this first parameter very accurately, it will not make much difference in y, but 2.44 is making a very good contribution. In total is 4, and this is making 2.44. And what is 2.44 I have got from D. So D I should measure very accurately, so that my percentage error in y is less. I hope you have understood this sum. So this sum had this point, that how to get the error bands. Okay. So if they have not subscribed so far, so you can subscribe to my channel, and if you have liked the numericals and the theory which I explained, you can like the channel and press the bell icon, so that you will get notification when I post the next video. Thank you.